So I have a situation here where I have a point A, which is located at 4, 0, and B, which is located at -2, 0, and I have some random point P, which is at an x-coordinate of x and a y-coordinate of y. Yeah. So then I need to determine I need to say the set of all points that describe P at any position such that the angle the angle BPA is always 90 degrees, right? How I have different points, you see how it works, right? That this angle always has to be 90 degrees. So I have to find a way to describe P so that all possible values of P follow this specific rule. So how I would do this, or how anyone should do this, maybe, a possible method is that because it's a 90-degree angle and we know this length, then we can start employing Pythagorean theorem, the Pythagorean theorem. So how it works is now we have this length BP and this length PA, and so we start playing around with a little algebra here. So what we do is, let's see, we have our point A, that was 4, 0, and B, which was -2, 0, and my point P, which was some x value and some y value. Okay, so then how does the Pythagorean theorem work? It was, let's see, that was AP squared plus BP squared is equal to AB squared. You can see that in the diagram here. So BP squared plus AP squared is AB squared. So you know a right angle triangle here, right? So then let's start plugging in a few values now. Okay, AP is, let's see, AP is, now we just employ the distance formula again. So then we have the square root of x minus 4 squared plus y squared, y minus 0 is still y. BP is equal to the square root of, let's see, we would have x minus 2, that's just x plus 2 all squared, plus y squared again, because now it's just minus 0, and AB would be, now let's see, we would have the square root of, let's see, that's just 4 minus 2, that is 6 squared, which just gets me 6. Okay, now what? Let's just plug it into this formula now, this above formula. Okay, so then we would end up with, actually, I'll just leave it as this. Okay, then I would have the square root of, because now I square it, right? So the square root goes away. So that I have x minus 4 all squared plus y squared. Now I have plus this one, x plus 2 all squared plus y squared. And that whole thing is equal to AB all squared, right? So that's equal to 36. Now what? Let's see, we can... Okay, so then let's try expanding the whole thing out. Maybe we can get a nice general equation, because when we have a general equation, that's what we're trying to solve for. Well, that's the aim of this specific problem. Then we'll have an x squared minus 8x plus 16 plus y squared plus x squared again plus 4x plus 4 plus y squared, and I'm going to subtract the 36 this time around, is equal to 0, because we want everything on one side and we want a 0 on the one side. That's how general equations work, you know. Okay, so then let's collect all the like terms. So then we'd have x squared, so 2x squared, then 8x and 4x, that gets me minus 4x, 16, and I have, let's see, 16, I have a 4, and then minus 36, that gets me minus 16, yeah, 16 and 4 gets me 20, 20 minus 36 is minus 16, yep, and I have a y squared and a y squared, that makes 2y squared, is all equal to 0. Now, these are all multiples of 2, let's just divide through. We have x squared minus 2x, let's see, that's just minus 8 plus, plus y squared is equal to 0. And this is the equation that describes the shape. Well, if I was to complete square, so then I would just have this, and so then I would have x squared minus 2x. Now to complete the square from here, then we have a minus 2, so then we would divide the coefficient by 2 and square it, right? So then we would divide by 2, then we would have minus 1 and square it, so we would have plus 1 plus y squared. Now, let's see, I have to get from 8 to plus 1. That means I added 9, so I have to subtract 9. Is equal to 0. Bring the 9 to the other side. So then I have x. Now, this whole thing I contract. X plus 1. No, x minus 1. Sorry. X minus 1 all squared plus y squared is equal to 9. So this tells me an equation of a circle. So we have our center located at, let's see, center is at, so my y coordinate is 0, x coordinate is 1, 1, 0, and my radius is the square root of this, which is a 3. And this is shown in our equation here. If I do, let's see, what was that? View algebra. Yep. Okay. So then here you see that we have a center, again at 1, 0, as we predicted, and we can see very clearly that there's a radius of 3. And you see that the set of all points that follow this is a circle. We're done.